All right, mathletes, here we are looking at completing the square. We're going to complete the square to solve quadratics. And typically we're going to do this when the factorization method, okay, does not work. So if we look at our quadratic and we recognize we have something like this, x squared plus 4x minus 7, and we try factoring it, a times c is negative 7, b is 4. We think of factors of negative 7 that can add and subtract to 4, and they don't exist. So at that point, we don't necessarily say there's no solution. Now this is our other strategy. Now we're looking at solutions that are irrational. Okay, so often involve surds. Okay, so with solving quadratics, remember we have three cases in which we can solve them. Okay, when we're solving by using the square root and completing the square, so if I have x squared is equal to some number k, and I try and solve this, well, to undo something that is squared, I take the square root. Well, I need to remember when I take the square root that, for instance, if this was x squared is equal to 9, I can see that x could be equal to 3 and also negative 3. So it's the square root of 9 plus or minus. So that's one scenario. Okay, that's when we have this value k, which is greater than 0. Okay. The other scenario is when we have it equal to x and k is equal to 0. We get x is equal to 0. That's just our one solution. Right. Previous one was two solutions. Okay. And the last one is when we're going to see that we're going to have situations where we have no real solutions. For instance, if we have this k value, so this number is less than 0, or that it's negative. Okay, so if we think of x squared equal to negative 4, well, no number. So if I tried to solve this, I take a square root here and a square root here. Notice it's a square root of a negative number. That number, if you try and type it in your calculator, you get a non-real answer. Okay, so at this point we're going to say there's no real solutions. Okay, so that's important to note here. All right, so when we're completing, so here with solving this one, we can see solving this quadratic, it's nice because this quantity is a perfect square. Okay, so undo something that's a perfect square, I take the square root of both sides. Okay, and I get x plus 2 equals, well, now I have to remember if I take the square root of something, I have a positive answer and a negative answer of the square root of 11. Okay, square root of 11 is irrational, so we're just going to leave it as a surd. Now to get x by itself, okay, I'm going to subtract 2 to both sides, and I get x equals negative 2 plus square root 11, and I get negative 2 minus square root of 11. Okay, so I get two solutions here. Okay, this is the most basic type of solving this quadratic just by taking the square root. Okay, so sometimes we have to form that perfect square. In this previous example, notice, we had a perfect squared term here. Sometimes when you look at quadratics, that perfect squared term does not exist. Okay, so we need to form it ourselves. The process of creating this perfect square on the left-hand side is called completing the square. Right? So to complete the square, and we'll look at more of this in class, we always need to look at our b value. So our b value is here. It's our coefficient of x. This is our b. And to complete the square, we're going to have to add things to both sides. Okay? So what we're always going to do is we're going to take that b value divided by 2 and square it. And that's what's going to go on both sides. So for our example here, our b is 4. So we're going to do 4 divided by 2 squared. Okay? So 4 divided by 2 is 2. 2 squared is 4. Okay? So now I'm going to take that number and I'm going to add it. So this 4 here, I'm going to add 4 here. I'm going to add 4 to the right side as well. Okay, and then I had my minus 7 equals 0 plus 4. Okay, so notice I just added 4 to both sides. Well, by adding 4, okay, I have something that's going to factor into a perfect square. So if I look at this piece here, I have x squared plus 4x plus 4. I know if I look at that quadratic, okay, that can factor into x plus 2 times x plus 2. Okay? And x plus 2 times x plus 2, because they're the same factor, I know I've done this right because I can get x plus 2 squared. Okay? Well, notice what I have left here. I have a minus 7 on this side, and on the right side I have 4. Okay? So now what I want to do is I want to isolate my perfect square. So I'm going to add 7 to both sides. Okay? And I get x plus 2 squared is equal to 11. Now to solve this, just as I did before, I'm going to square root both sides. I get x plus 2 equals plus or minus square root 11. Subtract 2 from both sides, and I get x equals negative 2 plus square root 11, and I get negative 2 minus square root 11. Okay? So the big thing to notice here is that we always need to take our b value and divide it by 2 and square it, and that's going to be our term. So this is something you're definitely going to want to have in your notes. Okay? So let's look at an example that you'll see in your problem sets. Okay? So find what must be added to both sides of the equation to create a perfect square, the left-hand side. Write the equation in this form. Okay? So first step here, figure out what needs to be added to both sides. Okay? So I'm going to look here. Here's my b value. So that's 8. So I do 8 divided by 2 and squared, right? That was from our previous slide. B divided by 2 squared. That's always what's added to both sides. 8 divided by 2 is 4 squared. 4 squared is 16. Okay, so 16 is my answer to that part. Write the equation of the form x plus p squared equals k. So I'm going to have x squared plus 8x plus, and I'm going to add this to both sides, plus 16 on the right side, and then I had this was equal to negative 5. Okay, so I just added and introduced this piece. Just like when we solve equations, sometimes we add things to both sides to get them equal to 0. Well, here we're just adding both sides so we have the resources and the tools to make it a perfect square. Okay, so now if I look at this quadratic, okay, I do my a times c, and I get 16, and I get 8, and they should be a perfect square, 4 and 4. So I get x plus 4 times x plus 4 is equal to negative 5 plus 16 is negative 11. Okay, x plus 4, since it's the same thing, I can write it as x plus 4 squared equals negative 11. Okay, I'm sorry, this should be positive 11. Okay, so now we have written in this form x plus p squared equals k. Okay, let's look at another example here. So here we're going to go ahead and solve by completing the square, and we got to do all those steps to eventually get there. Okay, so first thing I'm going to do is I'm going to look at my b value and make sure I carry the sign. So I have negative 5 divided by 2 squared. Well, negative 5 divided by 2 is just a fraction, so I have 5 over 2. And I'm going to square both sides, and I get 25 over 4. Okay, I'm going to rewrite this equation. I have x squared minus 5x. I'm going to add this value, so plus 25 over 4. And I know I'm going to have to add it to the other side as well. Okay, this is plus 3 equals 25 over 4. Okay, look at the pieces I started with. Okay, and I'm going to look at my terms. Okay, well, I know my b term. Okay, if I look at this previous example, this 4 here is always just the square root of this value here. Okay? So in this example, if I take the square root of 25 over 4, that's going to be x, and because this is a minus sign here, it's going to be x minus 5 over 4, okay, and x minus 5 over 4. Okay, they multiply to be, it should be negative 5 over 2, square root both the top and bottom. So negative 5 over 2 there. So notice that negative 5 over 2 multiplied together is 25 over 2, and negative 5 over 2 added together is equal to negative 10 over 2, or negative 5. So I completed the square. Okay, and then I have a plus 3 equals 25 over 4. Okay, so I can simplify this. This is just x minus 5 over 2 squared plus 3 equals 25 over 4. Before I take the square root, I need to isolate this value on this side. So I'm going to subtract 3 to both sides. So I'm going to get x minus 5 over 2 squared equals 25 over 4 minus 3. Simplify this. I know I'm going to want to get a common denominator, so I multiply negative 3 by a form of 1. Okay, so I get 25 over 4 minus 12 over 4. And so this is going to be equal to 13 over 4. At this point, I have x minus 5 halves squared equals 13 over 4. Now that I've gotten it in this form, I can solve by using my square root. So I take the square root of both sides, and I get x minus 5 halves is equal to plus and minus the square root of 13 over 2. Square root of 4 is 2. So the square root is now just in the numerator. And then I'm going to add 5 halves to both sides. So I get x is equal to 5 halves plus square root of 13 over 2. Or it can be 5 halves minus square root of 13 over 2. So my solution is a set of two numbers. Okay, let's look at one more example here. Okay, so notice on this example, I have an a value. Okay, so just to deal with problems when we have an a value, we're just going to want to divide that out originally. So this is equal to 0. So I'm going to divide this side by 3, divide this by 3. So I get x squared plus 2x minus 2 thirds equals 0. Okay, so now that I've dealt with that a value, I do it very much the same as I would before. My b value is 2, so I do 2 divided by 2, and I square it. Well, that's 1 squared, so I'm adding 1 to both sides. So I'm going to have x squared plus 2x plus 1, and then I'm going to add 1 over here, and this is a minus 2 thirds. Okay, so again, I look at this piece and look for my perfect square. Well, if I go like this, things that multiply to 1, that add to 2, well, that's 1 and 1. So this is going to simplify to x plus 1 times x plus 1 minus 2 thirds, which is equal to 1. Okay, well, since it's something that's multiplied by itself, it's x plus 1 squared. And then I'm going to also add 2 thirds to both sides on this step. So I get 1 plus 2 thirds. Well, 1 is the same thing, so I multiply it by a form of 1, which is 3 over 3. So I get 5 thirds. Okay, so I have x plus 1 squared equals 5 thirds. Now it's of this form, a perfect square on the left side. I can go ahead and square root both sides. I get x plus 1 equals plus or minus square root of 5 over 3. And then I subtract 1 from both sides. And I get x is equal to -1 plus square root of 5. That square root should go all the way over 3. And -1 minus square root of 5 over 3. Okay, so that's your lesson on completing the square. Please highlight any questions you might have and bring them to our next class.